So, hello everyone. Today we are going to solve this question. This question is the question that is from Z table, and it proceeds as follows. The burn time of a certain rocket fuel follows a normal distribution with mean, that is 4.76 seconds, and standard deviation, that is 0.05 seconds. The question says, using Z table, calculate the probability that the burn time is less than 4.6 seconds, is more than 4.6 seconds, and is between 4.6 and 4.8 seconds. So how do you solve this question, right? So in order to solve this question, first of all, we need to know the formula of Z. So we know that the formula of Z, first of all, we'll state the given values, all right? That will be much more effective. So we know that the mean, that is mu, is given by 4.76, and we know that standard deviation sigma is given by 0.05, right? Now let us consider x be the variable representing the burning time. So the first case, we have probability of x is less than 4.6 seconds. And in this case, we need to apply this formula, that is probability of x minus mu by sigma is less than, right? Now we will apply the value of x, that is 4.6 minus the value of mean, that is 4.76, and then we will divide it by standard deviation, that is 0.05, and this will give you probability, and this quantity is z is less than, right? Now when we calculate it, 4.6 minus 4.76 divided by 0.05 gives you minus 3.2. So this will be minus 3.2. Now let us say that we keep this value as it is for now. We will solve for all of this, and then we will proceed to the Z table in order to find out these values, all right? So now the next case states that the probability that the burn time is greater than 4.8 seconds. So it states x is greater than 4.8 seconds, and for this case also we'll apply the same thing, is greater than 4.8 minus 4.76, 0.05, and this will give you probability of z is greater than 4.8 minus 4.76 divided by 0.05, and it will give you z is greater than 0.8. And the last scenario is probability between 4.6 and 4.8, so it's 4.6, 4.8, so it will give you the value, that is the probability will be from 4.6 minus 4.76 by 0.05 is x minus mu by sigma is less than 4.8 minus 4.76 by 0.05, and this will give you probability of z is minus 3.2 is greater than, sorry, is less than x minus mu by sigma is less than 0.8. And when you actually try to, this value down here will be considered as z, right? Now if you really write this in this form, you can get p is 0.8 minus p minus 3. So this is the answer that we get. Now I'd like you to see what does this mean in a z table or a graph. Alright, so what does a mean in a graph? So let's say that we have the normal distribution, right? Now I like to draw the normal distribution. Very sorry. Let us make this symmetric about this plane. So let us assume for now that this figure is symmetric about this axis. Draw symmetric axis. Alright, let us assume that this graph is symmetric about this dotted line. Now P is minus 3.2. So if this point is the origin point, and if this side is negative and if this side is negative and this side is positive, so if this side is negative and this side is positive, now we will get here, let us say that, I'm sorry, so let us say that this side is negative. Now we get here a point that is minus 3.2, then the area covered in this region is the value of probability of z is less than minus 3.2. Let us say that this is greater than 0.8. So we have 0.8 somewhere here. Now when you look at the z table, right, when you look at the z table will always give you the value of the area that is less than the given value. So when I find 3.2 in the z table, the z table will, so let's say we have the z table function fz. When I plug in the value of the function of x, right, when I plug in the value of the function of x in this z table, when I plug in the value of x, that is minus 3.2, it will give me an area that is less than minus 3.2. So when I plug in the value of 0.8, it will give me an area that is less than 0.8. So that means when I plug in z, it will give me this area, this whole area in the z table. Alright, it will give me this whole area in the z table. But we are not meant to find this area because we are said that z is greater than 0.8. So what we need to do is, since we know this is the normal distribution and the whole thing have an area of 1, so when we find the area on this side of the graph, that is when we find the area on this side, when we find the area on this side, so we will subtract 1 from 0.8 and we will get the value of 0.2. Alright, so this is the value. this is the value of uh, pz is greater than 0.8. What if someone says you the value of x from 4.6 to 4.8? So when we have z that is minus 3.2 to 0.8, so it lies between minus 3.2 to 0.8, then we get the value of pz is less than 0.8 from z table. So we get all this area, all right, and then we again get this area. So that means for minus 3.2 we have already covered this area, right? We have already covered this area. For minus 0.8 we have covered this whole area, so when we subtract these two area, that means this small area from this bigger, this whole area, you will get what is left in the middle portion, right? So you will get what is left in the middle portion, and that means it will be this area, right? It will be this area, and that is what this graph, that is what this statement minus 3.2 less than 0.8 says, right? Now we are going to switch on to Z table in order to find out the values, right? I'm going to add on screen so that all of you can see the Z table. Okay, so I hope Z table is visible. It's an is. So at first the question had said us to actually find the value of Z is less than minus 3.2. So this is the negative Z table and this is the less than negative Z table. So first of all, you need to find the value of minus 3.2, and since the Z table only deals with two decimals in the back after the decimal digit, only 2 points after the decimal digit. So since we only have 3.2 and the last digit must be 0, so we go at 3.20 and we look at the value of 3.20, and that will be 0.000069, right? So that value will be 0.0069. That is the answer, right? That is the minus 3.2 answer. Now sometimes the Z table, now the another value that we wanted to compute was we wanted to calculate, okay, this is I think the positive Z table. We wanted to calculate Z is greater than 0.8. So from this Z table you can see that this is the plus Z table and this is plus 0.8 only. So when you the decimal digit that we had in our question, right, decimal digit that we had in our question was, you can see that the decimal digit that we had in our question was actually 0.8 only, and the last digit was 0.80. So if you see the value of 0.80, it will be 0.78814. Now we had learned that if we the Z table always gives you the less than value, right? So the Z table always gives you the less than value. So we had learned that if we find this value from the Z table, right? If you find this value from the Z table to be, so from the Z table you find the value of 0.8 to be 0.78814, then you can certainly keep 0.78814 as the value. So P Z is less than 0.8 will be equal to 0.78814. That means this area in this direction, so all this area that is less than 0.8. But since we are meant to find out Z is greater than 0.8, so we know that whole area is 1, so we will subtract it from 1 minus 0.78814. I have already discussed about this, and we will get the answer, the final value, that will be 0.2119, and this we had already find out to be 0.0007, right? It was 69, I round it off. Now we had reached to this conclusion where we wanted to find 0.8 minus 3.2. Now 0.8 is this value, 0.78814. Remember that I said when we write p 0.8, it's always the less than graph. So all the less than area that falls from 0.8 up to this point will be included when we write p 0.8, and that will be 0.78814, and minus 3.2 will be all the graph that will be from minus 3.2 to this infinite point. And when we subtract these areas from the larger area to the smaller area, we get this yellow shaded portion. So now we will get 0.0007, and we will get the value as 0.7874 as our final answer. So I hope you understand the whole process of how this works and how the value is found. And that is all about the explanation of Z table, and how to find values using Z table, how to apply the formulas. In the future sessions, we'll be diving into questions that are a little bit complex than this, but we will be going much more faster because this was the base class, and after the base is covered, we will be moving much more faster in our coming sessions. Thank you very much. Hope to see you in the next video.